For problem 1.1, it states that Hooke's law says that when a spring is stretched x units beyond its natural length, the elastic force f of x exerted by the spring is f of x is equal to negative kx, where k is a constant that depends on the spring. Assume that k is equal to 12 inches. Part A of this problem says, if a string is stretched at a constant rate of 1/4 inch per second, how fast is the force f of x changing when x is equal to 2 inches? So for our original problem, we have f of x is equal to negative kx. And then we know for part A that the constant rate of change, which would be dx dt, is equal to 1/4 inch per second. Pause. We also know that k is a constant at 12, so we'll write that. And for part A, we know that x is equal to 2. So we can do our original equation. So f of x, to find the derivative of f of x, we do df dt is equal to negative kx, and for k we can do 12, so we'll say negative 12 times dx dt, which is 1/4, and that is equal to, so the df dt for A is negative 3 inches per second. That concludes our answer for 1.1. Now for question B, we're asked to do the same equation, except our x value will no longer be 2. It is now equal to 3. So we do df over dt is equal to our constant k, negative 12, times dx dt, which is still 1/4 because it's a constant rate of change, which makes our df dt the same thing no matter what x is, because the dx dt is still 1/4 inch per second. So no matter what we put in, we'll always get negative 3 inches per second. For problem 1.2, suppose that cos x plus y minus x squared plus y is equal to 0, where x and y are both functions of t. If dy over dt is equal to 2, when x is equal to pi over 2 and y is equal to pi over 2, find dx dt. For this next part, we will take the derivative of the equations. We have negative sine x plus y, since it's a chain rule. And then we times it times the derivative, which is dx dt plus dx dy minus 2x dx dt plus dy dt is equal to 0. Our next step is to substitute in all known variables. So we'll have negative sine pi over 2 plus pi over 2 times dx dt plus 2 minus 2 pi over 2 dx dt plus 2 is equal to 0. Pi over 2 plus pi over 2 simplifies to pi, and the sine of pi is equal to 0. So we have 0 times dx dt plus 2, which is equal to 0. So we're left with negative 2 pi over 2, which simplifies to pi, dx dt plus 2 is equal to 0. Our next step into solving for dx dt is to move over the 2, which leaves us with negative pi dx dt is equal to negative 2. Alright, the next step is to divide by negative pi, which will give us our answer. Dx dt is equal to 2 over pi, since the negatives cancel out. And that is our dx dt, our final answer.